So, do you have any advice that you would give to someone to get started? Because from my experience, you don't jump right into that type simulation as a starter.
I would say if you have the chance to practice your knowledge or develop your knowledge, it's very important that you explore the extremes of simulation in case of CFD. For example, the physics is too broad. You need to choose where to start. For example, you know so well when you have a piping flow. You have a very good feeling about just by looking to the boundary conditions and the dimensions, you can already have the feeling, oh, here you need this and that. And then you don't need even a software to do that. It's just paper and pen. And then you go to the software, doing this over and over again from different problems, different geometries. This starts giving you so much confidence, and then you start advancing to different physics. So I think it's the practice that makes you good.
In today's episode, I'll be talking with Jose Fonseca. Jose is the CAE Group Manager for FS Dynamics in the Hamburg, Germany office. He has over 14 years of CFD consulting experience. Thanks to FS Dynamics for sponsoring today's episode. I hope you enjoy our conversation, and please like, subscribe, and hit the bell so you don't miss an episode.
Welcome to the podcast, Jose. Thank you for joining.
Thank you very much, Kate, for inviting me. Thank you very
I'm
much.
really excited to be able to talk with you. So, one of the questions I'm always interested in is how people got into simulation and CFD. So, can you share with us what your first exposure was and how you got started?
Well, I am Brazilian, so I graduated in Brazil as a mechanical engineer. And my experience with fluid dynamics was more experimental in university. And then I found an internship back in Brazil. And there I started working as a mechanical engineer, doing mostly experiments. And I was very glad that the team that I ended up, they were also very fan of modeling. But it was more into, like, say, hand calculation-ish towards simulation, so more 1D approach. And this was back in 2008. And I have a pleasure to work with very smart people and highly motivated and young people in that time that they were trying to do things different. And I then moved to another role as a thermodynamics expert, where I was responsible for the thermodynamic efficiency and reliability of reciprocating compressors, which the cross collaboration with structural, acoustics, and reliability team, product management, everything was, this cross collaboration was very important. And my role also involved testing and lately simulations. So the company was started like pushing, okay, can we do something different? Can we use simulation, hand calculation, 1D, 2D, 3D, to try to bring insights or understand why the experiment is giving such results? And there where my, let's say, adventure on industrial CFD started. And as you can imagine, that was 2008. We are a lot of years ago. The industry was still adapting. So there was a lot of skepticism about, okay, what CFD does. Not everybody knows, especially management. What can you do? And also involve cost of license, hardware, computational power. And this was a kind of an impediment. So once they give you the chance to do CFD, you need to make sure that you're going to deliver something meaningful. And that was the challenge. I started in that time, we are developing commercial compressors that has a higher capacity than household compressors, for example, which means higher capacity basically means different refrigerants, bigger mass flows. Well, pressure drop will increase. So was the first step? Let's use CFD to redesign the suction system, discharge line systems using CFD. And that's where everything started. So I already knew CFD back from the university where I work with turbulence. And also I helped building a academic, I'll say, wind tunnel. And when I saw that opportunity rising in the company, I said, oh, why not? I try myself. Of course, there was an expert there, a senior engineer, which was way more advanced. He knew he was working CFD for probably already 10 years.
Mm.
So I start teaming up, talking with him, try to learn as much as possible. And yeah, and then I would say then that where everything started, and was from pressure drop to then more transient simulation, heat transfer, and then we are doing two-way coupled FSI, which was in that time was like it was the most advanced computation that we could do. So it was very, very interesting.
Yeah. I just want to touch on, you made a statement that I had found so true as well. When starting CFD in a company, the importance of getting a quick win, right? Doing something meaningful that provides value. Can you elaborate on how you came to that conclusion on your own? Was that like, because I feel like that's something many people struggle with, right? They think, okay, we're going to do CFD, but being able to sort out what's the most meaningful contribution we can make
Mhm.
with the simulation power we have. So how did you come to determining that?
Well, it's important to say that it's always difficult to know as a fresh graduate, just arriving to the industry is so much things to learn. You need to know
Mm,
how the organization work, what are the roles. Everything is so complex. You are kind of overwhelmed with so much information, and you also need to understand how the product works.
mm,
And that's the key point. Maybe other people have different ideas, but in my experience, key part to give meaningful simulation results to any analysis to know the product that you are analyzing, how that works, what's the purpose, what's the requirements and specifications. And lately, but not the least important, in fact, the most one, what's the goal of that analysis, what you need to solve. That's key to start. And then comes the second point that, of course, for me at least I came to know in my first experience. Good, Jose, you have a very nice result. Can you prove me that this is real?
mm.
How can you know that these results is true? And then it was the first time that I hear the word verification. Did you verify? And I said, oh, verify. Yeah, yeah. That's is a pressure drop on this line, right? Yes. If you look to the theory, for example, flowing tubes, how does your model is able to capture the physics? And I said, yeah, I think so. Then I started, okay, then I learned that the best thing that you can do, even before starting doing this 3D complex model, go back to the books, looks to theory, do some, check if the Reynolds, the basics, and see what, at least, can you check what you can expect. Then you do the simulation, you compare with analytical, you say, okay, well, at least I have the same trends. Having the same trends indicate that you are capturing the physics. And then it becomes more meaningful. And then of course, then comes the next step, which is validation, which is confrontation with the experiment. And then it's like let's say the cherry on top of the cake. And that's, I think, how you do meaningful contribution. The first step, understanding and verify. If you don't have experimental results to check.
Yeah. I think that's important too, that people understand this stuff takes time. That's why
Yeah.
experience is valuable, because it takes time to integrate and to assimilate everything that you're taking in as a fresh graduate, or even if it's a new position and you've been out of school for a
Yeah.
while, different industry, new product. A lot of this stuff does just take time in
Indeed.
grasping and understanding. But that's excellent points. And this kind of touches on my next question of, what do you know now about learning CFD that you wished you would have known when you started?
Well, when I start, I was looking to software, CFD software, high performance clusters. All this seems, of course, and the company makes clear that, okay, we are paying for it and expensive. So you kind of I was a bit afraid of, okay, should I use this? If I make a mistake, I spend the money. But in the end, it's it's a money well spent, because you need to make a collaboration or a comparison, between experiment and virtual experimentation. The CFD in your hand is basically you have a virtual flow thermal lab, a virtual laboratory that you can play as much as you want. If you play wisely, you can gain a lot of insights. You could experiment as much as you like, verify against theory, and let it validate. And you can learn a lot out of it. Once I learned that, I could much easier start growing the maturity of my models. A good example is you have a certain flow with a certain geometry, you calculate some Reynolds in certain locations, you know that you have a turbulent model, turbulence regime, and then you set up, but you read all the, let's say, guidelines of ERCOTAF and etc. about what is more useful, what turbulence model you should use. But in the end, you can also test different models that has the same applicability. So you could explore the CFDs, but you need, as I said, you need to explore wisely, always with a very one foot also on the theory, on the physics to be able. That's one thing that I learned later, to explore the capabilities of CFD on my own benefit. And later, it's one thing that I always tell also the people that work with me, whatever result you get, be critical when looking into it. Confront with theories and papers, peer review with your colleagues. If the result is not what you expect, doubt it. If it's too good, doubt it twice. So is being critical. That's what is important.
Yeah. I can't remember who quoted this. I'll have to put it in the notes, but it said the characteristics for a good CFD engineer are definitely not the same characteristics for the person you want in a long-term relationship, because you're always going to question things you're never going to trust.
That's
and you're
true.
going to be extremely
That's
critical.
true.
And I thought that was just a nice anecdotal way of conveying the mindset of question everything.
Yeah.
And that's a healthy mindset. So yeah.
You need to be also careful, because if you doubt, you tend to check, recheck, test, retest. You need to draw a line.
Yes.
And that's where comes the pragmatic approach.
Yeah. And what you test and how you test it too, right?
Yeah.
You could do 1,000 tests, but if you did 2 to 3 sound tests that get at the roots of it, then.
And now that we are talking, it came to my mind, is one thing that is very important to every start engineer, in my opinion, is try to understand what you need, what the project needs. Because each different phase of a project requires a different level of accuracy. Why you want to have like accuracy of plus or minus 2% if you are in a feasibility, you don't even have a concept. This is very important. It's not reading CFD related, is a kind of engineering approach. That's also a very important point.
Yeah, my major professor had a funny way of talking about this. He'd say, sometimes we design it with a micrometer, we test it with a micrometer, we design it with a tape measure, and then it's built with an axe. And so every time down the phase, you're loosening up the tolerances. And so just, yeah, exactly that, keeping that in mind of where we're at. So one of the things that I'm really interested in is the first time I read about this formally was in Versteeg and Malasekera's textbook, Introduction to the Finite Volume Method, Computational Fluid Dynamics. And they make a statement in the introduction. This is the second edition, 2007 then, about the time you would have been taking your foray into this career path. And they end their introduction by questioning if the real limitation in industrial CFD and it being deployed would be the limitation of enough suitably trained CFD engineers. And so one of the things I'm interested in is, you having worked in consulting and been in the industrial side of CFD, if you could change anything about the way engineers are educated, CFD engineers are educated, what would it be and why would you make that change?
Well, the education on CFD engineers, I think, is quite well done today. There is a lot of physics, there is numerics, and now with the machine learning AI is rising all the statistical part as well to be coupled with this education. But the industry, the needs of the industry is, and they are looking for engineers that are strong in physics and numerics and whatever come being added now. But what the industry require is, like I mentioned before, is the pragmatic approach. Where to draw the line, where is good enough for each different phase or each different project. And that's what I also face with many people, juniors, engineers that I normally work with. They are very good to explain what the theory of Y plus the boundary layer theory, all kind of theory. But when comes to sit in front of the software and make the choices to deliver faster results, then becomes, let's say, they start holding back. So I would say if I could change, I would be, of course, you keep the basis, and then you have a part of the study where you are focusing solving real problems, real industrial problems, from the simplistic to the most complex one, explaining your choices, why you did that based on theory. That I think that it's needed. And and in this step, it's important for the CFD engineers to be aware that understand the application, its requirements and specifications, identify the physics that are playing the major role there, and define the most suitable approach to tackle the problem. Such breakdown in a structural and well-based way will increase the confidence of the engineer, help him gain the trust of the people that are work with them, and enhance the quality of their deliverables. But also will help him to increase over time the maturity of his models.
So, do you think that that's best delivered from the university, or is that best delivered in a short course? Or do you think that falls on employers to finish out that training? Because it's a tough question, right? At least in my
Yeah.
university, professors are swamped with teaching courses. And yeah, it's a tough thing. I don't think there's any easy answer of where it comes from. But what do you think would be a suitable approach?
Yeah, that's difficult to answer. I can only say that the best school is life. Yeah,
Yeah. Yep.
I was there. I went
Yeah.
through it. Okay, it was painful, but it was also enjoyable. You're not gonna get a stand ovation, but you will fall. You will stand up. You will learn. You go. Sometimes you're gonna get some ovation. Maybe I'm still waiting for it, but but it's. I think it's the way it is. Yeah.
Yeah. Yeah. I remember during my grad school, I would often just take like a walk in the morning and in the afternoon, just think and kind of take a break, get outside. And I remember distinctly I think it was in the afternoon, I was walking and I was working on a really hard problem and it had stuck me for a while. But I remember having a very similar thought of this is what it's about, right? It's about becoming someone
Yeah.
who can solve problems. Solving the problem is the means to you becoming a better engineer, a better thinker, changing the way you approach. And as you were talking about that, it just reminded me of that experience that it's enjoyable. It really is.
It
Doing
is.
hard things
Yeah.
is enjoyable. And
Especially when somebody asks you something and you say, "Well, I don't know if we can do that. I think we can. Okay. What about if you try?" And in the
yeah,
end, you might end up even not answering the question that it was initially asked, but you might come up with different insights that helps the project. That's
yeah,
very rewarding sometimes.
yeah,
No, that's it's very nice, and it's increasing as well with time. Companies are more and more trying to be willing to invest and see, okay, what benefits can we get from it?
yeah.
Yeah.
So speaking of companies willing to invest, can you provide an overview of FS Dynamics where you work now?
Yeah. Well, FS Dynamics, it's not a new company. They exist already for 20 years, and they work in different industry segments, automotive, energy, nuclear, wind, aerospace and defense, many semiconductor, electronics, so many different sectors. And today we have over 140 CAE engineers working exclusively in CFD. And it's a company that's fully focusing in calculation, technical calculation, from a very, let's say, even hand calculation up to method development. The company, because you can imagine, for consulting companies, is very hard to survive in this let's say environment. But FS Dynamics focus their effort on building high competence and long term relationship with the customers,
Mm.
which is about not selling hours. We are not. We want to solve or help the customer solve the problem in such a way that they are very happy and with our quality. That if they have another problem, they can come to us again, and we're going to be, of course, happy to help them. And this recipe works over the 20 years, and FS Dynamics consolidated itself as the leading consulting firm in the Nordics. And in 2022, we started this office here in Hamburg, FS Dynamics Germany, where we, we as a strategy of expand our footprint to the Northern Europe. And today we have already here 12 engineers working in CFD, mostly to electronics and semiconductor. We have also people now working with vacuum simulations where we don't use the normal, the standard CFD. Let's put it this way. So because if you, depending the pressures, you are in different regime, your Knudsen number is too high, so you need to go to use Lutz-Boltzmann method or direct simulation of Monte Carlo. We also working and developing competence where we already have a very, very, very nice project in plasma simulations and also recently molecular dynamics, which is a new field for us, which we are exploring with some customers right now. And as more customer comes, of course, we are always in a search for new talents, which we see every now and then LinkedIn some vacancies.
Yeah.
Yeah.
So that's exciting. It's really exciting on the growth
Yeah.
and where you're headed, both in terms of physics and footprint and people, like lots of dimensions of that growth.
That's true. It was very fast. 2 years. It was very challenging, and but it was most of all, it was very, very exciting. I could work different people, also would see different industries, which also give you a different perspective as well.
Yeah. So, along those different perspectives, what do you think are some common misconceptions people have about working in CFD as a consultant, right? We talk about generally, okay, the transition from academia to industry,
Mhm.
but even within industry, things can be quite different. And
Yeah.
so, working as a consultant, what do you think are some misconceptions that people have?
Well, when I was in other companies, I also hired externals, consulting companies. So I'm not saying that all of them are equal, of course not. Every company is building a certain set of values and a strategy. So I don't want to generalize here, but in FS Dynamics, we are not company that you're gonna hire us to deliver, for example, plots of pressure and velocity. Just say, please do, can you run this geometry with this boundary condition? And then I will give you back just with the pictures. Of course, we can do if you ask, but our focus is on performing the high-end, most complex CFD and FEM and plasma vacuum or molecular dynamic simulations. So we aim to that part. And to do it properly, when you hire us, our idea is that we understand in depth how the hardware of the machine works. The depth that is required to do the job, of course. What are the requirements, specifications to make sure that we can add the most value as possible to the customer? So it's not just about executing, it's about understanding and give back something more than just plots, some conclusion, some direction to the customer. That's what I think that we are different, and that's the misconception. Consultant doesn't mean simple guy that you consult. What's the velocity in this location. Here's the velocity. But what that means, we want to add more.
Yeah.
So
So as you continue to advance in your career, what do you feel like are the ways that you do that, right? Because so where I'm coming from here is I have a lot of people reach out, and one of the questions I get is, how can I get started doing this type of work, right? They want to have their own consultancy. And so, do you have any advice that you would give to someone to get started? Because from my experience, you don't jump right into that type of simulation as a starter, right? You have to learn and layer it line upon line and develop that expertise over time.
hmm,
So, what advice would you give for someone wanting to move in that direction and just starting out?
I used to say that it's difficult to give advice because if advice was good, we would sell it, right? I would say if you have the chance to practice your knowledge or develop your knowledge, it's very important that you explore the extremes of simulation in case of CFD. For example, the physics is too broad. You need to choose where to start. And you need to I think, gain feeling about things. Uh, what I mean with feeling about things is, for example, you know so well, for example, when you have a piping flow, you have a very good feeling about just by looking to the boundary conditions and the dimensions, you can already have the feeling, oh, here you need this and that. And then you don't need even a software to do that. It's just paper and pen. And then you go to the software, doing this over and over again from different problems, different geometries. This starts giving you so much confidence, and then you start advancing to different physics. So I think it's the practice that makes you good, is the and also the persistent, because it's not gonna be always fun. But the overall, in average, it will be pretty much fun. But you
Yeah.
need to try. Only books and tutorials is not enough. They are a good start to warm up. But there is plenty of papers on the internet with simulation and experiment that you could start trying to replicate, for example. That's also a good start, especially if they are published by industries.
Yeah. So,
Yeah, but that's difficult to give a good advice in that sense.
I think that's great advice. So, we should charge for that segment. Um, because it kind of comes into these next things. I'm going to ask you to spill the beans a little bit on your interview strategy here, because that's another thing I know people really wonder about. And you said a few comments that I just jotted down here that really stood out to me. Physics is too broad. The Navier-Stokes equations and simulation equations, transport equations encapsulate so many different applications in industries that sometimes people are just overwhelmed and bewildered of where to even apply for a job, right? A CFD engineer, the title, the title CFD engineer on a job opening is not equal across all companies. And I think
No.
for freshers, that can be confusing and disorienting to them and looking at that. And so as a team leader and manager, could you give us some insight into the way you approach your interview and why you ask questions and what you're really looking for? Because in my experience, there's a lot more that goes into the assessment of a candidate that's difficult to put out in a job posting.
Yeah, that's
And
true.
what you're able to put out, really, you're doing the best you can. But just the system is not optimized, let's say. And so what things are you really looking for in candidates?
I need to be careful not to ruin my interview strategy here.
That's right. I don't want you to spill the beans too much.
Yeah, but well, usually I kind of have three steps approach. My first step is to assess the personality of the candidate. My intention here is to see if he, she, or they will fit into the team. Because, well, if you don't fit, there is no point even to look if you know CFD. And about fitting is also about fitting to the team, into the company, is about attitude. I'm always looking for people which has these, you can see in his body language, in the way that they speak, also a kind of attitude like that they will not leave any stone unturned until they solve the problem. Huh? The person that will, if you have a simulation running, he is his baby, This is you see these sparks on the eyes of the person. That's what I'm looking to. That's the attitude that I want. And secondly comes, of course, is second, but not least important, is does he or she or they have enough CFD knowledge? When I say about this, what about meshing, physics model, post-processing? And we also assess, for example, physics itself. And then comes the third point, is about how much physics knowledge and feeling for real application the person has. Imagine if I ask one question I always ask is related to evaporation. You said if you have your t-shirt is soaked with water, then you put outside. Then I always said, when it's gonna dry faster? In a sunny, wet day or in a cloud, but still dry day? These kind of questions. And I ask why, depending what you choose. So it's questions that are physics-based answer, and they think you need to. And I said, what factors plays a role? So these things is very important. And also what and how is, I'm more interested on how the person reasons about the problem that she's trying or he's trying to solve. If he can explain it and communicate the results in a meaningful way. Another example is, imagine that I ask you to translate, let's make a nice parallel here. If you have a memory card, flash card of 32 gigabytes, but if I ask you, please, Kate, translate this, each transistor to a grain of sand, how much sand do I have? That's the one question that I used to do, but I will not do anymore. But and then you're going to end up with 5 times 10 23. What does this number mean? If I need to transport this sand, 5 times 10 a power 23 does not help me to find if I need a truck, if I need a container, a ship, or, you understand? So communicating results in a meaningful, useful way, it's very important. These are the 3 things that I look in a candidate: attitude and fit, CFD knowledge, and physics, and good, meaningful communication.
Yeah, that is very, very insightful. And do just want to point out the sequence. And you mentioned this as well. The sequence of that, I think, is often surprising to some people. How much teamwork and a fit really matters to companies, and how important and much of a priority that is. And so I think a lot of people come out of school because school is not graded that way. Success in school is not measured the same way that success in a company is often evaluated and valued. And so, right, if you had the top of your class, you didn't necessarily have to be a good team player to be the top of your class. So,
yeah, but it is very important, especially if you are a fresh graduate. In my experience, I learned a lot, of course, from the books and from my own, but I learned most when I was discussing with my colleagues, even not only the most experienced one, but also the juniors, because you guys, they are facing the same problem, but they have different perspectives.
Yeah.
And this helps a lot to see things and solve your own problems.
Yeah.
People don't realize sometimes.
Yeah. I read a quote the other day I really liked. It was something along the lines of, it's not that people don't know enough about things, it's that they know too much about the way things have always been done. And so having a freshness and an insight and just a new perspective can really add a lot. So
Indeed.
Continuing on this theme of interviewing, what's the most common mistakes that you see young CFD engineers make with interviews?
I think one thing, I can mention 3. One of them is not being able to explain their work in a concise and clear way. Usually you have 1 or 2 interviews. Normally we have 2. Sometimes we condensate at 2 interviews in one, doing 1 hour and a half. And one of the points is, can you explain, for example, we select or your PhD thesis or your master, depends, huh? And you say, can you explain these work? But we have limited time. So you need to be able to clearly select on your head what I'm going to mention, which is important to the interviewer to know about me, to get his attention. Huh? And that's what I see. A lot of people struggle to explain their work in a concise and clear way. The other one, as I mentioned in the previous question that you mentioned, is the difficult to translate the numbers in meaningful engineering conclusions. That's key. Is key now. It is key in university, but I think for an industry it becomes even more important. And the third is avoid answering like, okay, I don't know. If I make a question, if you don't know, just say don't know. But usually some candidates, they try to say something else or push towards something that they know, but that is not related to the question. This can give mixed feelings about that you might not be able to deal with unexpected questions. So, and the best answer there is honesty. There is no way out of it. This is my perspective. Huh? Somebody could have other perspective, but for me, if you don't know, you don't know.
Yeah. One of the things I just like to ask you, one of the things that I've counseled people is to acknowledge that they don't know, but then to say, this is how I might approach it based on first principles or
Yeah,
something. So to acknowledge it, but not to stop there. Because if you get a problem you don't know, you acknowledge you don't know it, but then you're going to move on, as we talked earlier, right? And start solving it. And this is how I might go about it too. So I think that's something that I noticed in professors. My respect went up when a professor would say, I don't know, but here are my thoughts on it, versus the professor that when they got asked a question, I mean, I'm not trying to pick on professors. I just remember this very distinctly as a student, professors getting asked questions and them not knowing the answer and try to stumble through it. And it was often obvious to the rest of the class that they
yeah.
just didn't know. So,
I had a candidate that he didn't know one of my questions, and then interview finished. 2 days later, he sent me an email with all the explanation he could find with an slide and everything. So then after that, I just invite him for a talk again
yeah,
because that's the kind of his attitude.
yeah,
So it's not page turn. Of course, you also need to be willing, really want the job, to after
yes,
an interview do some digging and come back.
yeah,
So, and I mean, I also have this myself as well. I had assignments where they throw me to the lions, and in one meeting I said I don't remember how many I don't know I said, but I said I don't know. I will check and I'll come back to you. There is no shame on it.
yeah,
It's shame if you try to answer something else that's completely off.
yes,
Well,
yeah, absolutely. So thank you. Thank you for those insights. And hopefully we didn't spoil it too much.
no,
Um, you
it's
have
okay.
plenty more things up your sleeve, huh, for the next round of hiring round. So switching gears here a little bit, you talked about this early in the discussion of your experience with cross collaborations and working with structural teams and other teams early in your career. But what have you learned about the importance of those collaborations and clarifying the objectives internally and externally? I guess where I'm going with this, maybe a little more context, is for our listeners that oftentimes my experience has been some of the hardest parts about a CFD project are not the technical aspects. It's defining clearly the scope. And so I just want to see if you could give some insight on how you've learned to clarify and do that, because that's essential to your work as a consultant.
That's true. Especially as a consultant, you are not part of the organization that you are working for. So there is the importance of cross collaboration and alignment is even more important, I would say. So I would say that cross collaboration or clarify objectives is key in that sense. As most of the simulation involve more than one physics, and collaborating with different competences become essential. So, and that's okay. Um, Reflect us back to what I mentioned in the beginning. Understanding what is happening, what physics plays a role, will basically define how much competence we need to talk to. and how many different sectors you talk to. And then in the start of the project, it's paramount that you clearly define the objective and the expectation for all parties involved. You need to sit with them and say, guys, that's my plan. That's the answer that I want to answer in this time. And what do you expect for each of those answers? What do you expect to have? Because maybe they say, he's going to answer this question. Great. But then I deliver just the pressure plots, but the other team, the acoustic team will be happy, but the thermal team will be, oh, where is my temperature plot? Why you didn't, So you need to align. And of course, align takes time, but the time that you might get for the delay time might be even longer if you don't do the alignment. So it's this, let's say, time that you spend aligning, it will pay off considerably.
Yeah. It's a measure of prevention, right?
Yes, yes. It's a wise step to structure well the beginning.
Yeah.
Yeah.
Yeah. So what has been maybe a favorite project or one that stands out to you that you've worked on with CFD at FS Dynamics, and why has it stood out or why has it been a favorite?
That's a difficult one because I have worked in so many different projects, and it's hard for me to choose one. But I can, well, I will start saying that I can tell what type of project are my favorite.
Yeah.
I really enjoyed to work with those projects where they, the team or the project itself gives you freedom to think out of the box and use CFD to test different ideas.
Mm.
This normally gives you the opportunity to expand your perspective in terms of modeling, and also to also give you the opportunity to add even more value to the project because you are going beyond. And recently, I have one project that we are working on, which is, well, for me, is still in progress, but has been very, very challenging, which we combine plasma simulation, CFD simulation, and molecular dynamics. I am a CFD person. I came from CFD. We have a plasma expert and also a molecular dynamics expert. It's very hard to, let's say, to grasp a bit of everything now as a manager to be able to talk with those guys. Because, I mean, I see as a fluid dynamicist, I see plasma only as an ionized gas and that's it. And I rely on my people. But what I find amazing of this is the different on the scales, time scales, but also the length scales and the physics itself. It's so amazing to see that we are on the macroscopic universe going towards the angstrom universe. It's astonishing, and that's why if I would need to pick, I would pick this one because it's the even though I'm not the person doing it, but I'm involved as a manager. It's very nice to see and challenging as well.
Yeah, that sounds amazing. Which really brings me to another point I wanted to ask of these trends, right? You talk about, and I don't think people appreciate, I know I didn't appreciate how quickly the changes are happening in simulation. And so, and the trends that we're seeing, right? Even just 16 years ago or whatever it is, that CFD was not being deployed like it is today. And we forget how far computing power has come, even in just a few years, right? And so,
Mhm.
what trends are you seeing as a consultant from customers, clients with adopting simulation, both in terms of the level of physics that we're now able to do, right? You talk about going from the macro scale to the angstrom scale. But yeah, what are those trends that you're seeing in whether it's the type of work you're being asked to do, or maybe the type of approaches and those open-ended things that you're able to bring in because of your expertise and really provide value. But
It depends. It depends of the customers. Now, what I see, the big customers, the big enterprises that has quite they invest quite heavily in CFD. We see automotive industry, naval industry, semiconductor, for these more experienced kind of customers, that are applying simulation already for years, the trend is more towards paving the road to build a structured way of working to enable their digital twin.
Mm.
Of course, beautiful word, beautiful concept is the digital twin. But as big, as complex is the machine or the hardware, more difficult it is. Especially machines that has thousands of modules coupled with each other and communicating with each other. And for some industries, the digital twin are more close because of the simplicity of their product. Some of them is more far away because it's way more complex. So, but what we see is that we are receiving more and more requests of working with reduced order models. 1D system simulation, like for example, Modelica, Daimler, where CFD is oftenly used to, to as an input for those activities on a reduced order model and a 1D simulation. That's what we see a lot. And of course, we see also the trend of a lot of companies creating AI engines that need CFD data to train their algorithms. This also is trending a lot, and the big enterprise they are also investing on on this, but it's still for very very complex simulations. I think it's an effort ongoing. And continuing my reasoning, if you look, we are doing more and more simulations. I think the world is doing more and more simulation. More data is generated. A big challenge coming up, or it's already in place, is how to manage all this simulation data. So the famous simulation process data management. How to make sure that everything that you create from the cut to the result is traceable. This is problem already for a lot of companies are tackling it, but it's going to become bigger and bigger with the application of AI and machine learning because they can generate even more data to train and data as an output. And this is, we don't provide consulting or SPDM, but that I see all the interaction with the customers, they are concerned about it. And FS Dynamics customers are becoming more and more receptive to using simulation to improve their designs. We see more and more customers coming and say, "Hey, I have this design. I would like to see where I put my inlets and my outlets. Are they the correct places to to fulfill a certain requirement?" And more companies are approaching us with an open mind to discuss, "Hey, we have this issue or need. Can you help us?" And that's a kind of a very big difference if I look like 15 years ago, where if you come offering, "Hey, I can help you," before you test it and see that it's failing, you can do a structural analysis and see that's going to be failing. No, you cannot do that. Today is more like, "Oh, can you do that?" The tone has changed. The question is the same, but the tone has changed. So these are basically the trends that I see.
Yeah. That's really exciting to hear about and to see that's good news for us, right? Good news
Yes.
for CFD engineers and those interested in making it a career and a field for them and laying out a roadmap of that. Because one thing that I didn't touch on, but I guess I wanted to, on second thought, kind of tying into this, is you see this growing demand, right? And it's been a theme throughout the conversation. You've grown, FS Dynamics as a company has grown in footprint,
Mm.
personnel, in capabilities. Are you finding that you're able to meet that talent need, or is it taking you a bit longer to fill roles than you'd like, or are you able to get the talent that you need?
We we have received kind of an overwhelming amount of CVs. For every vacancy that I open, I think the least amount of CVs that I have received was like the minimum was 170. There is vacancies that I received 350, which I manage myself those applications. So it's also hard to give feedback to everyone. But
That's
I have,
overwhelming.
yeah, it's overwhelming. And I had been in the other side looking for a job, of course. And every time that I look to the CVs, I sympathize with people that sometimes does not get a feedback. But now I understand why. But looking to the talents, all of I have seen so much good CVs, and I think most CVs, they seem very good when you read them, but they are not very clear. So organization of a CV is very important. And some people also underestimate the importance of a cover letter as well. But I think there is talent. Today, with the globalization, I think it's quite easy to go from one place to another. We have quite a lot of nice applications for all over the world. In my office today, we have 8 nationalities, which I found quite nicely from, and this is also give a very nice vibe. But yeah, I think talent-wise, we can find. We're still hard, but I think to find mostly people on the, let's say, on the range between 3 to 6 years of experience, that's very hard to find. I find a lot of juniors and mostly, and sometimes more towards senior or principal, and it's like above 6 or 10 years. But the range between 3 and 6, it's a very difficult one to find.
That's interesting insights. Well, thank you so much for sharing with us, and this has been a really enjoyable discussion, Jose. So thank you very much for all of this. This is a lot to think on and a lot for the listeners to ponder and go and apply. So thank you.
Thank you very much, Katie, for inviting me. It was a pleasure to join and participate of your CFD for industry, which has been quite successful. I have been watching and all the podcasts and the interviews. Congratulations, it's been a pleasure and it's very nice.
Thank you. Thank you very much.
Thank you for listening. Really, thank you. Did something about this episode stand out to you? If so, please go ahead and share it with others on LinkedIn or other social media so they can find this as well. See you next time.